In today's market, microservices have become the go-to solution to build any kind of application. They're often known to solve various kinds of challenges, but this is not the end to the story, as skilled professionals often face challenges while using this architecture itself. So hello all, this is Sahiti on behalf of Edureka, and I welcome you to this session on Microservices Design Patterns. So in the session, guys, we'll discuss on the various design patterns that you can use while setting up an application using microservices. So on that note, let's take a look at the topics for today's session. So the topics for today's session are, as you can see on my screen. We'll start this session by understanding why do we need design patterns, and then we'll look into what exactly design patterns are. After that, I'll tell you what are microservices, and then I'll talk about the principles behind microservices. Once you understand the principles behind microservices, I'll finally end this session by talking about the microservices design patterns. So I hope the agenda is clear to you guys. Alright, so that's great. So the first topic for today's session is why do we need design patterns? So to understand this topic, just consider a scenario where you have a team of developers, let's say 30 developers, right? Now you're given a project to basically build similar kind of applications. As a team lead, what will you do? You'll just divide these 3 applications to a group of 10 developers, right? So the group 1 will have project 1, group 2 will have project 2, group 3 will have project 3, and all these 3 groups will have each of 10 developers, right? So now when this team of developers start developing the application, they can follow different set of processes, right? So when I say process, what I mean that is the way they're developing the application, right? So they can follow a particular path to develop an application, right? So let's say the group 1 is following process 1, group 2 is following process 2, and group 3 is following process 3, right? Now, what can happen is that maybe process 1 works completely fine. What I mean by that is that, there's no error, and then whatever errors are coming also, there's no latency time, there's no disadvantage in using that kind of process, right? But if you consider any other 2 processes, let's say process 2 and process 3, it may happen that, there could be few errors, and maybe that's not the right way to build the application, right? So what could happen is that, I'm not saying that, process 1 is the only way to build an application. Maybe they have a better way when compared to process 2 and process 3, right? So as a team lead, what you clearly understand is that, your development team cannot build the application using process 2 and process 3, right? So to ensure that all the teams follow the same process or maybe a same pattern, you can use this concept of design patterns when the teams working on various projects use the same pattern to build similar applications, right? So basically, they'll select a particular pattern and they'll build all the applications based on that particular pattern itself. On that particular pattern, you'll make sure that you have the maximum advantages that you can get for your application, right? So that is the need of design patterns, guys. Basically, if you have to understand the need in a single line, then you can just understand the fact that design patterns are used to make sure that your complete team is on the same plate and everybody is following the same process or maybe the same pattern to build the application, right? So I hope you've understood what is the need of design pattern, right? So now let's understand what exactly design patterns are. With my previous explanation, you might have clearly understood that, design patterns are basically a simple pattern based on which you build an application. But yet, if I have to define design patterns for you, then design patterns or software design patterns can be defined as a software template or a description to solve a problem that occurs in multiple instances while designing a software application or a software framework, right? So I hope you've understood what exactly design patterns are. They're basically just a software template or a pattern or maybe a description to solve a particular problem. And that particular problem is seen in multiple instances, right? So when you want to solve a problem which is in multiple instances, you can go forward and choose the design patterns, right? So now that you know what are design patterns, let's move forward with what are microservices. Now I'm explaining you what are microservices in short. But yet, if you want a detailed explanation of microservices and how you can build applications, you can refer to our microservices playlist. So on that note, let's understand what are microservices. Well, microservices, or most commonly known as microservice architecture, is an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. So basically, you can have a business domain and maybe all the functionalities and the features are divided into various microservices. So in a microservice architecture, each service is self-contained and implements a single business capability. So for example, let's say you have an e-commerce application. Now, e-commerce application basically has customers, orders, and products, right? So basically, a customer basically gives an order for a particular product. Now what you can do is you can build this application based on microservice architecture by dividing the customers into a specific service, by putting the products into another service and the orders into the third service, right? So for this particular business domain or the e-commerce application, you can have basically three services, that is customers, orders, and products, right? So I hope that you've understood what microservices are. Basically, as the term suggests, microservices are basically small services communicating with each other to build a big application. Now, to build microservices or to model microservices, there are various principles behind it. So next in this session, let's look into the principles behind microservices. So the principles behind microservices are, as you can see on my screen, it starts with independent and autonomous services, basically because each service is independent of the other service, right? That is because each service is either created for a domain or a business capability, and each service has its own functionality, right? So that is the first principle. Coming to second principle, that is scalability. So when you build microservices, what you can basically do is, for example, let's say you have 4 services for a specific business domain. Then what you can do is you can scale a specific service individually without scaling the others, right? So let's say in the example that I took, that is the e-commerce application, we had 3 services, right? Customers, orders, and products. So if you want to scale the customer service individually, you can definitely go forward and scale that particular service, and you do not have to scale the orders or the product service. Similarly goes for the other services also. Coming to the third principle, that is decentralization. So decentralization is basically when you do not have a centralized architecture, right? What I mean by that is, for a specific business domain, when you build an application using microservices, your complete control is not there for a specific service, right? So all the controls are basically divided into individual services. Coming to resilient services, I would say microservices are resilient services because, let's say even if one service is completely down, the complete application will not go down. So in the e-commerce application, let's say if the product service is down, that doesn't mean that your application will stop working. Only that particular service is not working, and the team will be working on that particular service to get back the service, right? So the only point that you have to understand is that even if a service goes down, the complete application doesn't go down. Next we have is real-time load balancing. So obviously when a client sends a request, it may happen that you have to retrieve data from multiple services. Over there, the load balancer comes into the picture, and then it defines how much CPU or how much GPU should be used for a particular service to get the data, and similarly how the client's request should be passed, right? So that's happening real time, and in this kind of architecture, the client doesn't have to wait for a really long time, right? So you get the outputs within seconds. Coming to availability, I think the principle itself defines its functionality. It basically means that the services are available 24/7, and all these services can be basically used as much as they want, right? Coming to the next principle, that is continuous delivery through DevOps integration. Well, microservices is one such technology, or maybe one such framework that you can understand, which you can collaborate with DevOps to get continuous delivery of the output, right? So once you understand DevOps, you'll understand how to deploy a service and how to get the outputs, right? After that, we come to the next principle, that is seamless API integration and continuous monitoring. All the microservices have a specific API gateway, which is basically the entry point to the client's request, right? So whatever client's request has been sent, it will be first sent to the API gateway, through which the request will be forwarded to the specific microservices. And obviously these microservices are continuously monitored whether the response is sent back or not, or maybe if the service is down or not. Coming to the next principle, that is isolation from failures. So when I say isolation from failures, what I mean by that is, all the services, even if they're down, or maybe if they have any specific errors, that particular service will solve its own error and it won't disturb the complete application. So let's say in the e-commerce application that we considered, let's say if the product service is facing few errors, then what will happen is only that particular service will be basically taken into account and the errors will be solved, and those errors will not affect the application or maybe the other 2 services. Coming to auto provisioning is basically the ability to deploy the information by itself, right? So basically the service will generate the information for the client's request automatically without anybody's help, right? So guys, these were the basic principles behind microservices, that is independent and autonomous services, scalability, decentralization, resilient services, real-time load balancing, availability, continuous delivery through DevOps integration, seamless API integration and continuous monitoring, isolation from failures, and auto provisioning, right? So guys, I hope you've understood the principles behind microservices, right? So now once you start building microservices, you often face few challenges because of which you have to start using design patterns. So since this session is basically based on microservices, we'll be looking into the microservices design patterns. So let's get started with the first design pattern, that is aggregator. So when you hear the term aggregator, what comes onto your mind? In computing world, aggregator refers to a website or a program that collects related items of data and displays them, right? So even in microservices pattern, aggregator is basically a web page and invokes various services to get the required information or achieve the required functionality. Apart from this, when you basically build a microservices architecture, maybe a microservices application, by breaking down the monolithic application or the monolithic architecture, the source of output gets divided, right? So when I say monolithic architecture, you can just consider it to be a one big block, right? So when you break that one big block into small services, the source of output also gets divided, right? So this pattern basically proves to be beneficial when you need an output by combining data from multiple services. So if you consider a client sending a request and maybe if you need data from two services, then aggregator is a design pattern that you should go for, right? Now, how do you think that happens? So what basically happens is that, let's say we have two services. When a client sends a request and maybe that, we want the data from both these services. So what will happen is that both these services will be having their own database. So with the help of aggregator design pattern, what will happen is that, each transaction will have a unique ID. So based on that particular ID, the request will be sent and all the data will be collected from the individual services and the required business logic will be finally applied. After that, what will happen is that, whatever data is collected, it will be published to the REST endpoint. And later on, what will happen is that the data will be consumed by the respective services which require that data, right? So it could be a specific consumer or maybe a user or maybe a group of users or so on, right? So if you have to understand aggregator pattern, guys, it's really simple. So aggregator pattern is basically a web page which invokes various services to get required information. So whenever a client requires a specific information from 2 or 3 services, you can go forward with this aggregator design pattern. Also, before I move forward to the next design pattern, I would like to mention over here is that, aggregator pattern is basically based on the drive principle. So what happens is that, based on this principle, you can abstract the logic, that is the business logic, into composite microservices and aggregate that particular business logic into one service, right? So let's say you have a business logic, right? So that particular business logic, what you can do is maybe you can put that particular business logic into 2 to 3 microservices. Later on, what you can do is you can aggregate that business logic into one specific service, right? So for example, if you consider two services, service A and service B, then you can individually scale the services simultaneously by providing the data to the composite service, right? So that was about the aggregated design patterns, guys. Let's move forward with the next design pattern, that is API gateway. Now, microservices are built in such a way that, each service has its own functionality. But when an application is broken down into small autonomous services, there could be a few problems that a developer might face. Now, the problems could be, how can I request information from multiple microservices? How can different UIs require different data to respond for the same backend database service? Or how to transform data according to a consumer requirement from reusable microservices? Or how to handle multiple protocol requests, right? So guys, these are basically few problems that all the developers face. Well, if you wish to solve these problems, then I would say the solution to these kind of problems could be the API gateway design pattern. So the API gateway design patterns addresses not only the concerns that I mentioned right now, but also it solves many other problems. This particular pattern can be considered as a proxy service to route a request to the concerned microservice. So basically, as I mentioned before, API gateway is the entry point to the client's request. Also, being a variation of the aggregator service, it can send a request to multiple services and similarly aggregate the result back to the composite service or the consumer service, right? So the API gateway, as I mentioned, is basically at the entry point for all the microservices and can create fine-grained APIs for different types of clients, right? So maybe you have a client sending a specific request, or maybe the client B sends a different kind of request, right? So with the help of this particular pattern, you can create fine-grained APIs for all different kinds of clients and for the requests. Also, since developers are always concerned about, how to handle multiple protocol requests, API gateways can convert the protocol request from one type to another type. Similarly, it can also offload the authentication responsibility of a specific microservice. So once the client sends the request, these requests are basically passed to the API gateway, which acts as an entry point to forward the client's request to the appropriate microservices. Then, with the help of the load balancer, the load of the request is handled and the requests are sent to the respective services, right? So microservices also use the service discovery, which basically acts as a guide to find the route of communication between each of them. So when I say each of them, I mean two microservices. So microservices can communicate with each other via stateless server, that is either by HTTP request or message bus, right? So with the help of API gateway pattern, guys, a client's request is basically forwarded to the correct microservice. And even if there are different kinds of clients using different UIs or maybe different protocols, and they want the data from the same backend service, then API gateway design pattern is your solution, right? So I hope that you've understood what is API gateway design pattern. Now let's move forward with the next design pattern, that is chained or chain of responsibility. So the chained or chain of responsibility design pattern basically produces a single output, which is a combination of the multiple chained outputs. I hope that is clear to you guys, right? So as the name suggests, in this particular design pattern, what happens is that the client request is passed to, let's say, service A, and then the request is passed to service B, and then the request is passed to service C. Similarly, the response is first collected from service C to service B, and then from service B to service A, and finally it goes to the client, right? So as the name suggests, guys, the chained or the chain of responsibility design patterns produces a single output, which is a combination of the multiple chained outputs. So for example, if you have 3 services lined up in a chain, then the request from client is first received by service A, and then this service communicates with the next service, service B, and collects the required data. Finally, the second service communicates with the third service to generate the considered output. And what happens is that all these services response is sent again from service C to service B to service A, and finally to the client, right? So all these services use synchronous HTTP request or response for messaging. Also, until the request passes through all the services and the respective responses are generated, the client does not get any output, right? So guys, this is kind of a disadvantage in this particular design pattern because, let's say, you have 20 services lined up. And maybe the client request is a very big request, right? So until all the data is collected from all these particular services and then the response back is generated, the client does not see any output, right? So it's always recommended not to make any long chain, as the client has to wait until the chain is completed, right? But before I move forward to the design pattern, one more important aspect which you need to understand is basically that, the request from service A to service B may look completely different from how the request is from service B to service C. Similarly is the case for response. Maybe the response from service C to service B may be completely different from service B to service A, right? So that's what you have to understand about the chain of responsibility or chain design pattern, guys. Now, let's move forward with the next design pattern, that is asynchronous messaging design pattern. So what do you understand by this term asynchronous messaging? Obviously, the messaging pattern between microservices is not synchronous, right? So in the previous design pattern, we had discussed synchronous messaging, right? So that was because, service A communicates with service B and B to C, right? But in asynchronous messaging pattern, it's not necessary that, all the services communicate like, service A to B or B to C. Maybe service A can directly communicate service C, and maybe service C can communicate with service B, or maybe service B does not communicate at all, right? And service B communicates with service A, right? So basically what you have to understand is that, since the client waits a long time without any output in synchronous messaging, and maybe you do not want the client to wait for a long time, this is where basically you use the asynchronous messaging design pattern, right? So in this particular pattern, what happens is that all the services communicate with each other, but maybe they do not have to communicate with each other sequentially. So if you consider 3 services, as I just mentioned before, service A, B, and C, the request from client can be directly sent to service C and service B simultaneously. When I say simultaneously, what happens is that, the single request from client is sent to both the services together, that is service C and service B. So then what will happen is that, these requests will be in a queue. So when I say queue, you can understand that, it's basically a line of requests. So when a client request is simultaneously sent to 2 services, you basically build a queue. And apart from that, what you also have to understand is that, let's say the service A sends a request to service C. It's not necessary that, service C sends back a response to service A itself. Maybe it can follow a different path and then finally a response can be sent, right? So the path is not defined and it is not done sequentially in asynchronous messaging pattern, right? So guys, that was about asynchronous messaging design pattern. Next, let's move forward with the next design pattern, that is database design pattern or shared data design pattern. Now, for every application, there's obviously a humongous amount of data present, right? So when we break down an application from its monolithic architecture to microservices, it's very important to know that, each microservice has a sufficient amount of data to process a request, right? So I hope that point is clear to you. When we break down the monolithic application into small services, we need to make sure that, each microservice has sufficient amount of data to process the client's request. So either the system can have the database per each service, or it can have shared database per service, right? So when I say database per service, what I mean that is, each microservice in the system will have a specific database for themselves. And shared database per service is basically when 2 or 3 microservices together share a specific database, right? Now you can use the database per service or shared database per service to solve various problems. So the problems could be basically the duplication of data and inconsistency. Different services have different kinds of storage requirements. So the problems could be basically the duplication of data and inconsistency. Different services have different kinds of storage requirements. Few business transactions can query the data with multiple services, and denormalization of data is not easy, right? So to solve these kind of problems, basically you can use the database per service or the shared database per service, right? So if you have to solve, let's say, the duplication of data and inconsistency, and maybe different services have different kinds of storage requirements, or maybe a few business transactions can query the data with multiple services, I think you should go for database per service, as it will then be accessed by Microservices API itself, right? So each microservice will have its own database ID, which thereafter prevents the other services in the system to use that particular database, right? So only that particular microservice can access a specific database present for that particular microservice itself, right? So apart from this, to solve the issue of denormalization, you can go forward with the shared databases per service to align more than one database for each microservice. So what will happen is that this will help you gather data for the monolithic applications, which are broken down into microservices. But you have to keep in mind that, you have to limit these databases to 2 or 3 microservices, else scaling these services will be a big problem, right? So guys, that was about the database design patterns. Let's move forward with the next design pattern, that is the event sourcing design pattern. So the event sourcing design pattern basically creates events regarding the changes in the application state. So these events are stored as a sequence of events to help the developers track which change was made when and by whom, right? So with the help of this, you can always adjust the application state to cope up with the past changes. And also you can query these events for any data change and simultaneously publish these events from the event store, right? So once the events are published, you can see the changes of the application state on the presentation layer, right? So that was about event sourcing design pattern, guys. Event sourcing design pattern is basically used to create events regarding the changes in the application state, right? You've done a specific change and maybe you want to go back to the previous change that you have done. You can always use this particular kind of pattern to go back and see what changes was made and when and by whom, right? So that was about event sourcing design pattern, guys. Let's move forward with the next design pattern, that is branch pattern. So what do you understand by branch pattern? Obviously, as the name suggests, it's all about branches, right? So for a specific service, you can have different branches, right? So the branch microservice design pattern is basically a design pattern in which you can simultaneously process the request and response from 2 or more independent microservices. So unlike the chain design pattern that I discussed before, the request is not passed in a sequence, but the request is passed to 2 or more mutually exclusive microservices chains, right? So this design pattern basically extends the aggregated design pattern and provides the flexibility to produce responses from multiple chains or a single chain, right? So for example, if you consider an e-commerce application, then you may need to retrieve the data from multiple sources. And this data could be a collaborated output from various services, right? So you can use the branch pattern to retrieve the data from multiple sources, right? So the branch pattern is really simple to understand, guys. It's basically where you want to simultaneously process the request and the response from multiple microservices, right? So these could be either in a single chain or maybe it could be in multiple chains also. But yes, it's not necessary that the request or the response is done in a sequential manner. So guys, that was about the branch pattern. Now let's move forward with the next pattern, that is command query responsibility segregator design pattern. So command query responsibility segregator design pattern, or more commonly known as CQRS, is basically used when you want to query for a specific data, right? Now what happens is that when you have microservices design in the form of database per service or shared database per service, what happens is that you have limited access to database, right? So basically you cannot implement a query as the data is limited to only a single database. So In such scenario, we basically use the CQRS pattern. So according to this pattern, what happens is that the application will be divided into two parts, that is command and query. So the command part will basically handle all the requests related to create, update, and delete, while the query part will take care of the materialized views, right? So the materialized views are updated through a sequence of events which are created using the event source pattern that I just discussed before. So in the CQRS pattern, guys, you basically divide the application into two parts, that is the command and the query. The command will take care of the requests related to create, update, and delete, and the query part will basically take care of the materialized views, right? So with the help of this pattern, you can make sure that you have good access to your databases, and then the client's request is satisfied. Also, you can make sure that your materialized views are updated through a sequence of events, which are again created using the event sourcing design pattern. So guys, that was about the CQRS pattern. Now let's move forward with the next pattern, that is circuit break pattern. So the circuit break pattern, as the name suggests, is basically used to stop the process of request and response if a service is not working. So for example, let's say a client is sending requests to retrieve data from multiple services, but due to some issues, one of the services is down. Now, there are mainly two problems which we'll see. First, the client will not have any knowledge about the service being down, right? So he or she will be continuously sending the request to that particular service. The second problem that we see is basically the network resources will be exhausted with low performance and bad user experience, as the client, without knowing, will be waiting for the response to come back, right? So to avoid such problems, what you can do is you can go forward and use the circuit breakup design pattern. So with the help of this design pattern, the client will invoke a remote service via a proxy. The proxy will basically behave as a circuit barrier. So whenever the number of failures cross the threshold number, the circuit breaker trips for a particular time period, and then all the attempts to invoke the remote service will fall in this timeout period, right? So once that timeout period is finished, the circuit breaker will allow a limited number of tests to pass through, and only if those requests are succeeded, the circuit breaker resumes back to the normal operation, right? So just in case if the tests don't go through, then there will be a failure and the timeout period will begin again, right? So in this particular pattern, what you have to understand is basically that, when the number of failures cross a threshold number, the circuit breaker will trip for a particular time period, and then all the attempts to invoke that particular service will fall in that particular period, right? Once that time period is done, what will happen is that, the circuit breaker will allow a limited number of tests to pass through, and only if the tests succeed, it will resume back to normal operation, else it will show failure again, and again the timeout period will begin again. So with the help of circuit breaker pattern, guys, you can make sure that there is no exhaustion of the network resources with low performance, and always the user experience is kept at a good note, right? So that was about the circuit breaker design pattern, guys. Now let's move forward with the last design pattern for today's session, that is decomposition design pattern. So microservices are basically developed with an idea on the developer's mind to create small services with each having their own functionality. But breaking an application into small autonomous units has to be done logically, right? So to decompose a small or a big application into small services, you can go forward and use the decomposition patterns. So with the help of these patterns, either you can decompose an application based on the business capability or based on subdomains. So for example, if you consider an e-commerce application, then you can have separate services for orders, products, and customers if you decompose by business capabilities. But in the same scenario, if you design the application by decomposing by subdomains, then you can have services for each and every class. So here in the example that I had considered before, that is the e-commerce application, if you consider a customer as a class, then this class will be used in customer management, customer support, customer query, and so on, right? So to decompose, you can use the domain-driven design through which the whole domain model is broken down into subdomains. Then each of these subdomains will have their own specific model or a scope, that is basically the bounded context. So now when a developer designs microservices, he or she will design those services around that particular scope or bounded context, right? Either you can decompose microservices by business capabilities or by domains, right? Now, obviously, these patterns might be sounding very feasible to you. But yes, these patterns are not feasible for a big monolithic application. This is because of the fact that, identifying subdomains or business capabilities is not an easy task for big applications, right? So the only way to decompose big monolithic applications is by following the vine pattern or the strangler pattern. So the vine pattern or the strangler pattern is basically based on the analogy to a vine, which basically strangles a tree that it is wrapped around, right? So when this pattern is applied onto web application, a call goes back and forth to each URI call and a service is broken down into different domains. These domains are then hosted by separate services, right? So according to the Strangler pattern, two separate applications will live side by side in the same URI space and one domain will be taken into account at an instance of time. So eventually what happens is that, the new refactored application basically wraps around, or you can say strangles or replaces the original application until you can shut down the monolithic application, right? So guys, that was about the strangler pattern, and I hope you've understood what is decomposition pattern, right? So guys, with this note, I hope you've understood the different microservices design patterns. So if you have any other idea about the different design patterns that we can implement in microservices, please comment in the comment section. Until then, that's all from my side today. I hope you found this session informative and you learned the different design patterns for microservices. So on that note, I end this session today. Thank you and happy learning.